So what I'm going to talk today is about a data center in terms of energy landscape, how it looks like. And when we are looking at optimization, obviously we are looking at a big ticket item. So obviously data center is one of them, and I will probably next slide will explain why I'm saying so. Obviously why it is important to optimize the energy and also to improve the uptime, which is one of the key parameters for data center. And by the way, today's this particular call on Zoom is possible with the help of data center only because this is being hosted by Zoom. So we are all connected and we are using data center in our day-to-day life. So that means you can understand the importance of data center in our daily life. So it is one of the important factor where we are utilizing it. We are putting the queries on ChatGPT. That means we are consuming the energy indirectly. So obviously it is important to optimize that. What's our approach in terms of achieving this optimization? How we use AI ML based solution for doing that? How it helps in terms of monitoring as well as looking at the data? How it can help in terms of improving the uptime for the data center? And last but not the least, in very brief, what exactly we do in terms of data center. So that's a brief agenda for the first 10 minutes. I'll quickly try and run through that. Now, if you look at the global electricity growth, and within that, data center plays a major role. And people say that, I mean, in US, it is already racing towards the number of 10% as an overall consumption of a country, which is a huge number. And in India, we are talking about 1 gigawatt or 1.5 gigawatt as an current data center consumption global, I mean, in India, which is maybe 1-2%, but it is definitely going towards 5 to 8 to 10% kind of growth. And the announcement you must have seen in the recent past where AWS is talking about 17 billion in terms of investment, and Satya Nadella was here in India talking big about data centers in India. So there is a huge growth for this particular element or the animal, and that means we cannot ignore it because this is obviously contributing to a big percentage of the overall consumption of an country. Now, within the data center, if you look at the breakdown, see on the right-hand side, the 50% of it, or almost 45 to 50%, is on account of cooling. That means the servers which are doing the application or running the application needs to be cooled. That heat needs to be taken away, and that is consuming almost 45% of the energy, which means there is a huge scope to optimize this and making sure that we are able to optimize the energy from the AI or ML perspective. And that's what we will be talking in the next few minutes. What we are doing is we have partnered with a company called Equilibrium, and we are trying to leverage AI to balance, obviously, the people, planet, and profit. It is obviously once we optimize energy, obviously we are saying that it will be reducing the carbon footprint. So we are making the planet much more friendly in terms of the carbon footprint, and obviously it will also improve the profitability of the organization. So it is trying to have a balance between all three. How we do it? We do it using the inputs from variety of different sources, which so there are IoTs, there are sensors which are being installed from variety of different devices within the data center. It could be also the BMS system, it could be the data lakes. And we take those inputs, and there are algorithms and the AI which is being modeled or trained on variety of different assets. And that's how it actually creates a digital twin. And it not only gives the real-time alerts, it will also give a prediction in terms of what can go wrong. So that's one aspect. Second is also in terms of improvement of or the optimization of the energy. So where we are going wrong or where we could be going wrong, and what are the probable ways. So it is not just telling you that this is going wrong, it is also telling you what and where it is going wrong, and what are the recommendations which the system is generating. So it's an actionable insights which has been generated by the platform, and that is something helping the user. So it can be connected to a ticketing system, and the action can be taken based on that. I'll show you some screenshots to have a better understanding that how it works. So we call it as a single pane of glass because you can monitor everything in your facility at one location, and almost 90% of the industry equipment are being covered. So it's a vendor agnostic platform. So we work with variety of different chillers, generators, UPS, all the equipments which goes in a data center. It can work on that, and it's a partner mindset. So it's not that it's a one-way traffic. We also get engaged with customer, explain to them what is the data talking about or what the AI is giving the inference, and we also understand what is the input from the customer side. So it's a partner mindset that we have, and that's how the platform has been designed and been working. And as you can see, our tagline, we see a tangible results in 60 days. So we are not just talking theory, but it will be actually being a quantifiable or the measurable outputs through this. Now, this is possible using the Octopus intelligence. And why we say Octopus intelligence? Because there are multiple systems in a data center, okay, or in a facility, you can say, where the pumps are driving the chilled water. There is a cooling tower, there is a chiller, there is a UPS. So there are multiple things, and you need to understand everything as a whole. You cannot be looking at one individual equipment in isolation. And that's where this Octopus intelligence comes into the picture, which actually able to help optimize the energy consumption and also able to predict in terms of where there could be a probable downtime. It can alert the user, making sure that you can take care of it before it actually happens, right? So that's how this particular platform works. So when we say AI, it is not about just one equipment, but it is for the overall system and how it is diagnosing it and how it is taking care of overall system. Now, from the monitoring perspective, let's say if I got data centers across, let's say Singapore, one in China, one in Europe, everything I can monitor in one dashboard, looking at what is happening in which facility, whether my power PUE stands for power usage effectiveness, which is a kind of an energy factor, you can say, for a data center, which tells that how efficiently it is running, or there is a more losses in a data center. So, and there are scope to improve that. That means obviously it is directly connected to your energy bill. So it's one of the important factor for any operator or any data center player for that matter. So it will tell you, so it has a capability to monitor this across and then able to tell that which facility is probably having some challenges and what needs to be addressed. So if you can see that red dot, so that means that particular facility has some scope for the improvement because there is something which is not in line with what it should have been. Now, this is something as a prediction in terms of PUE. So it is telling you in advance that probably if the things continue like this, probably next 2 days or next 3 days, probably your consumption is going to go up because of whatever the AI is able to predict. And it will not only tell you that, as you can see on the right hand side, the corner, it is also telling you that what are the influencers which are affecting this. So it is telling you that probably chiller plant efficiency is something which is affecting it. And this could be 3, it could be 5, 10. I mean, you can program it what you want to see. Okay, but on this case, we have just taken 3 influencers to give you an idea that what it is showing. So it is actually pinning down to what are the probable challenges, and so that you can look at that and take a corrective action. And so this is IKW per TR, a term which is very common for the chiller consumption point of view, or the chiller efficiency, that how much is the input kilowatt it is using to generate what tonnage. And it is showing that probably it is going on the increase, or there is a possibility, or that is showing that it is going on it is rising, and it is giving a recommendation that what you should do. So as I said, it is not only stopping at telling you that something is going to go wrong, but it is also telling you that what can go wrong and what are the probable reasons for that, and what are the actions which are there. So it's an actionable insights which the platform generates. it can be connected to a ticketing tool, so the ticket can be generated. Somebody from a service side can go and actually check that or take a corrective action based on the ticket. So that's the beauty of the system. And it has all the metadata for a variety of different chillers. So it captures that, and it will tell you that where it is going wrong. So as you can see, the picture in the red, or the figure in the red, is indicating that it is more than what it should have been, and the reasons for that, and what could be the probable reasons and the actions for that. So other parameter which I talked about is not just the energy optimization, but also the uptime, because obviously you can't afford to have your data center going down. People are obviously concerned about data center going down. It's a major risk or a major thing for any data center player. And if we are able to predict it using AI as something what we are bringing to the table, so it is actually telling you that probably your chiller motor temperature is going to go up in next few days, and you need to take an action. So it is telling you that before there is a failure, it is warning you in advance, and it is giving you a corrective action that what needs to be done. Same is the case for UPS. So for variety of different equipments, the platform provides this. I will just run through this very quickly. I've got a 10-minute slot. I don't know how many minutes I've consumed, but I'll try and finish it up quickly. Similarly, on the UPS efficiency part, so this is also another factor of energy optimization for the data center, because the cooling and the power is the two major factors in a data center, making sure that the servers are running. And if there is any reduction in terms of efficiency, that is directly affecting your energy consumption for the data center. Also, in terms of a data hall as a whole, that if there are any temperatures which are going beyond what it should be, so it is able to predict that, and it's able to predict that where it is going wrong and what corrective action it is able to take. So from the monitoring point of view, it can actually look at each and every point in a data center, and there are probably thousands of it in every data center. So it can monitor, it can do the analysis, it can predict what is going wrong and what can be the corrective action. So you can look at like an asset level. If you want to have a summary, this particular picture is saying that probably 20% of assets are unhealthy. Unhealthy means it's not that they are not working, but probably it is not working as per what it is supposed to be as a whole system, and then how it can be taken care of. Similarly, we are all concerned about making sure that we have a less in terms of carbon footprint. So there are dashboards for greenhouse gas emissions, and what are our KPI targets for that, and how we are able to achieve that. So that's at a dashboard level. So at a facility manager level, or the head of the facility can look at the dashboard to see that how his facility is running. And how this smart sense work is, it is sitting on top of your systems, like it can be an IoT devices, or it can be a BMS system, and through an MQTT gateway, it is collecting the data. Obviously, the model has been trained, and then it is being trained on a particular data set, also on a data center. It compares that, and it will study those particular sites. So there is a period of 10 to 15 days, we typically say that at site, where it gets familiarized with that particular site related conditions, because your Chennai power consumption could be different than in Mumbai versus in Delhi. So you need to make sure that your model gets accustomed to that or tuned to that, and then start generating the insights. Just two slides on what we do. So we are a data center EPC company. We do design, build, and operate data center, but at the same time, we offer ESG also as a service for data center customers, and obviously AI-based tools for decarbonization. And we have built more than 27 data centers, including for people like Amazon, Microsoft, Vodafone, and so on and so forth. So we have been doing this in India, Middle East, and Africa, and we continue to grow, looking at newer geographies and growing further in terms of the geographies. So lastly, for this particular platform, what we are talking is, as I said, in the quantifiable numbers, we have seen that we could able to achieve almost 20% in terms of reduction in terms of energy spent. Productivity is improved because a lot of automation is possible using the platform. And of course, yes, reduction in the maintenance cost, because now you are able to predict whether something is going to go wrong, and you can take a corrective action before actually that particular unit going to go down. So you can take an early action on that part, and these are the achievable results or the quantifiable results what you get out of the platform. So that's all from my side, and in case if you want to know more, or if you want looking for optimizing your data center for energy or improving the uptime, do not hesitate to reach out to us, and we'll be more than happy to connect. That's all from my side. Thank you.